Okay, 6.1 bisectors.
Remember what a bisector is. A bisector is something that cuts a line segment or an angle in half, into two equal parts. So our objective is to identify and use the properties of perpendicular bisectors and angle bisectors in a triangle. So remember, perpendicular, symbol for that, looks like that. That means 90 degrees. Bisectors cut things in half. So a perpendicular bisector cuts a line in half, and an angle bisector cuts an angle in half. So a perpendicular line is a bisector is a line, ray, or segment that is perpendicular to a side of the triangle at its midpoint. Notice it does not have to come from a vertex. So in our first example, we have this marked and this marked equal, meaning that E is the midpoint. But notice that for E to be perpendicular, it is not coming from the vertex. But in our second triangle, we have equal side segments. So D is the midpoint. And BD is our perpendicular bisector. It's perpendicular to the base, AC, and cuts AC completely in half, exactly in half. So BZ is a perpendicular bisector. Draw it on the picture. Okay, so this is actually a good talking point because BZ as a perpendicular bisector is actually not possible. So if you drop the line straight down from B, like so, and made it perpendicular, it would have to come down straight down and intersect OY at 90 degrees. Well, you can clearly see that this and this are not equal to each other. So if we made BZ right here, it would be perpendicular, but not a bisector. So if we want to say BZ is perpendicular to OY, we can do that. It just won't be a bisector. Now, let's go back and make a bisector. But to do that, we will need to say something like XZ. So what we do is we find our midpoint, and you can measure, or you can estimate, just for this case, and say, that's my midpoint. Here's another one, I'll make this X and Z. And you just do this, and now you have marked it perpendicular and bisecting OY. Angle bisector, a segment that cuts an angle into two equal angles. And it must come from a vertex because that's where the angle is. So notice AB cuts angle A into two equal segments. Now this we can do. BZ is an angle bisector. So what we want to do is we want to draw BZ somewhere like that to where these look pretty equal. If you want to be specific, you can get out a protractor and measure the angle and divide it by 2 and then mark it. We will have to be specific later with that, but for just the rough notes, you can just kind of sketch it right now. But in the room, we can use the protractors. Okay, triangle MIT. MO is an angle bisector. So let's just make a triangle. And MO is an angle bisector. So this is where M is going to be split. So MIT. MO is an angle bisector. So I want to cut this angle in half to make this section and this section equal to each other. IMO is 2x plus 8. And TMO is 6x minus 12. Find x and IMO. So first off, we set them equal to each other because we know a bisector cuts into two equal parts. I'm going to subtract 2x from both sides. Cancel that. I'm going to add 12 to cancel this. That gives me 4x equals 20. And when I divide by 4, I get x is 5. Now, be careful and pay attention to what it asks you to find. X and IMO. So IMO comes up this way and comes down this way. So that's this angle right here. You got to make sure it's not asking for IMT, which would be the whole angle at the top. So we're plugging 5 into 2x plus 8. So angle, the measure of angle IMO is 18 degrees. So is TMO. And angle TMI would be 36 degrees. PUT. US is a perpendicular bisector. PUT. I know I want U to be where my bisector is because it says US. So I'm going to come straight down, perpendicular, and bisect. There's US. Now it says USP is 2x plus 20. Find x and the measure of USP. Well, we already know USP is 90 because it has to be if it's a perpendicular bisector, but let's find x. So I subtract 70 from both sides. 20 from both sides and get 70. Divide by 2, x is 35. And of course, if I plug that back in, 2 times 35 is 70, plus 20 is 90. And I say the measure of angle USP is 90 degrees. Like I said, it had to be given because we drew a perpendicular bisector. So what is the perpendicular bisector theorem? If a point lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. Using this theorem, we would know that AB is congruent to BC. So EG is a perpendicular bisector of EFD, triangle EFD. Find x. This plus this must be equal to each other because it's bisected. So 5x minus 17 equals 3x plus 1. Notice these are congruent. Minus 3x from both sides and add 17. 17 is canceled here, and 3x is canceled here. I have 2x equals 18. So divide by 2, x is 9. I want to plug 9 in right here. I get 45 minus 17, which is 28. Or I can plug in 9 right here. 3 times 9 is 27, plus 1 is 28. SU is perpendicular bisector of angle TSR. Find x. Once again, notice these are congruent, but these are going to be congruent also because it's a bisector. So we set these two equal to each other. 5x minus 30 equals 2x plus 24. Subtract 2x from both sides and add 30 to both sides. You do this in 2 steps or 1 step, whatever you're comfortable with. The 30's cancel, the 2x's cancel. I get 3x is equal to 54. Divide by 3, x equals 18. And if we plug it back in, we find out that they are, in fact, equal to one another. Okay, angle bisector theorem. If a point lies in the bisector of an angle, then the point is equidistant from the sides of the angle. So if you see here how these are equal to one another, then any point like P there is going to be equal from either side. So Px is equal to Py. And notice these are perpendicular. So since it's an angle bisector, this is equal to this. 4x minus 1 is equal to 2x plus 5. Subtract 2x from both sides and add 1 to both sides. Cancels. I get 2x equals 6. Divide by 2. X is 3. We plug it in, we find out that each angle is 11. Now, RU is the bisector, an angle bisector. We see 19 and 19. This distance here and this distance here are equal. So 2x plus 5 equals 7x. I'm going to subtract 2x from both sides, which gives me 5 is equal to 5x. Divide by 5, and x is 1.